Hi, I'm Tom English, and this lesson is on ratios and proportions. Ratios are just a way of expressing the relationship between two items, and what we could do is think about two triangles. We say triangles are similar if their angles are all the same, and by similar we mean they're the same shape, but they can be in different sizes. In fact, our example here, we have a little 3, 4, 5 right triangle, and next to it we have another triangle. The same angles, which make them similar, so therefore we're saying the ratio of the sides is going to be the same. And the way we calculate that is to set up the ratio. First of all, ratio, you can express it as A colon B. A is to B. You read it the same no matter how you have it set up. Just write it out as A to B or as a fraction, and most often you'll see it as a fraction. And again, it isn't limited to two items. You can say, for instance, with the three angles here in the triangle, we could say side A is to side B is to side C. And it just shows you have those three relationships. A proportion then is just one ratio is equal to another ratio. And that's where the similar triangles come in. The ratio of their sides are equal. And if we take the familiar 3, 4, 5 right triangle, we can say that the side AB is to side DE. In other words, the ratio of those two sides is going to be the same as the ratio for BC is to EF, and for AC is to DF. If we know the numbers, for instance, in this case we say, well, this is the 3, 4, 5 triangle, and all we know is this side is 6. So we would say 3 is to 6 as, let's say 4 is to X. That's what we're trying to find. And to solve that, the easiest way when you have fractions equal to each other is to cross multiply. So for instance, we could say 3 times x is equal to 4 times 6. Now, another way to think of this is that the letters or the numbers on the outside are considered, they're called the extremes, and the ones in the middle are called the means. And you'll often hear the term the means equals the extremes. And all this is cross multiplying. In other words, 3 times x is equal to 4 times 6. 3x is equal to 24. And simple algebra, we divide by 3, so x must be equal to 8. So we can come down here and say, well, it's AB to DC, so, or DE, so DE would be 8. Same ratio, 5 is to, it'd be that 3 is to 6 as 5 is to X. Solve that. Now, what I'd really like to see you do, though, is instead of going through all that cross multiplication and so forth, hopefully your mental capacities will say, oh, wait a minute, look at this. The denominator is twice as big as the numerator. Oh, well, then this denominator has to be twice as big as the numerator. In other words, the sides are doubled, aren't they? And you can just look at that and say, okay, if 3 is to 6, that's doubled, so double 4 is 8, double 5 is 10. A lot simpler. Look for those kinds of things when you're doing these problems, because not only will you get the answer quicker, but it's probably going to be more accurate because you're not going through all the calculations. Another thing about proportions, we want to show that if we have a triangle as an example here, and we draw a line parallel to any one of the sides of the triangle, we're really setting up proportions. in the same way. In other words, and you think of this, we can prove it through our parallels crossed by a transversal, because that's really what you have here. If you think about it, we have FG, if it's parallel to AC, then we've just got one triangle within the bigger triangle, don't we? Because they all have the same angles. So again, we can set those up, and if you have more than one, what you have is a similar proportions, in that the ratio, if this side is double this side, then x is going to be double that, and y is going to be double that. Okay, do you see that? You can set them up as ratios equal to each other, but you've got the same thing. And that's one thing that's nice about with the parallels in there, and it doesn't have to be a triangle. You could have any parallels crossed by a couple transversals, and this section x is to y as, let's say 3 is to 4. Then if we found out this was 6, then this is 3 times y is equal to 24. This would be 8. Again, 3 is doubled, 4 must be doubled. So that's a handy little thing, a way to use proportions. There's something called the triangle mid-segment that I know you're going to get tested on. And basically what that's saying is, if you draw the parallel to a side of the triangle, and if you do it at the midpoints, in other words, this D is the midpoint of AB. So I show that this segment is equal to this segment. And E is the midpoint of this side, so that BE would be equal to EC. Now, what that's going to do, if you think about it again, we can prove that we've got similar triangles. Okay, we've got the 3 angles are equal, so the triangles, so we're going to have the same relationship for all 3 sides. So if, for instance, BD is equal to 1/2 this longer side, then also BE, this side, is, these two are equal, so it's equal to 1/2 that. So what's that say about our midpoint section there? Well, DE is going to be half of AC. So seeing that, if you saw some numbers up here, and this turned out to be 4, you know that's going to be 8. Just remember, it's the midpoints, that line, that mid-segment is going to be half of the base, or the parallel side. Okay? We're probably going to do a few more in this, but hopefully you get a feel for ratios and proportions. I think you had some of this back in Algebra 1 as well. So hopefully this isn't all completely new to you. Thank you.